Hello guys, today we're gonna do what are the conditions for a number k to lie between the roots of any quadratic equation. So first of all, let us assume our quadratic equation is ax square plus bx plus c. Okay, then what are the conditions such that any random number k lies between the roots of this equation. Okay, now first of all, if a number k lies between the roots of this quadratic equation, then the first which is obvious, the condition is that this equation must have real roots and the sign of fk. Okay, this is the fx function, and if we put the if we will plug in k in this function, then this function has the sign of fk and the sign of a should be opposite. Okay, should be opposite. Okay, I will tell you about why this sign should be opposite. Like suppose if the sign of fk comes out to be positive, then the a should be negative. If this sign comes out to be negative, then a should be positive. So I will tell you why this is the case. So we know that, like, this is our x-axis, this is our y-axis. Okay, and fx equal to ax square plus bx plus c. Okay, now first of all, let us assume a is positive. So a is positive, we all know, if in any quadratic equation, if a is positive, means the coefficient of the x square is positive, then the parabola opens upwards. Okay, like this. So now k will be these are our two roots. This is let's say this is alpha, this is beta. Now k should be we want k to be between them, so let's assume k is here, then this value will be fk. So it is very clear, since if a is positive, then our parabola opens upwards, and due to this, the value of this fk is on the negative side of the y-axis, which is negative. So this is our negative, and once again, let us see if our a is negative. So if a is negative, then we all know that our parabola opens downwards like this. Okay, this is our alpha, this is our beta. So our k, suppose it is here, then fk will be positive. Okay, so that's why this sign should be opposite of each other. So now let us finally, let me write the condition. What will be the condition such that the k will lie between the roots of any quadratic equation? The conditions are, okay, the conditions are: first, that d should be greater than 0, means that discriminant should be greater than 0. D means b square minus 4ac. Okay, and second condition is a times fk should be less than 0. Okay, why this is the case? Because I already told you about that a and fk should be opposite sign. So if this is positive, this will be negative, so the product will be still negative. That's why this is, if this is negative, this will be positive, and again their product will be negative. So that's why we have a times fk is less than 0. So these two conditions you have to keep in mind while solving any problem of such kind. So based on this, let me give you a question. Okay, the question is: find all the values of a, okay, so that 6 lies between the roots of x square plus 2a minus 3x plus 9 equal to 0. Okay, so this is our question. So first of all, we will apply these conditions here. Our first condition is d should be greater than 0. So from here we can find its discriminant, which is 2a minus 3. Okay, you know that already, right? This is a is 1, this is b, and this is c. So this b square minus 4 into 1 into 9 is greater than 0. It means, okay, means 4a minus 3 square minus 4 9 the 36 is greater than 0. Now we can cancel out 4 9 the 36. Okay, so here it is a minus 3 whole square minus 3 square. So we can now use the identity a square minus b square, which is a plus b and a minus b greater than 0. This will be simply a, and a minus 6 greater than 0. Okay, now what we will do, and if we have reached at this point, so most probably you will already know how to solve these inequalities. Okay, so first of all, what to do here, we just write the critical points which are a equal to 0 and a equal to 6. So we will plot these on the number line. This is 6, this is 0, and we will, from the rightmost part, we will label it positive, then negative, then positive. Now since this is greater than 0, we are interested on the positive side. So we will, the solution will lie between here and here, which is our a, okay, will belong to, see, minus infinity to 0, minus infinity to 0, union 6 to infinity, union 6 to infinity. Okay, now let's leave it like that, and now we will apply our second condition, which is a times fk less than 0. A times fk less than 0. Our a is, you can see from here, it is 1 times, now we will, this is our fx, we will put k here, so k square, okay, plus 2a minus 3 into k plus 9 into k plus 9 less than 0. And k, now the k is given, which is 6. Okay, so 6 square, which is 36, plus 6 to the 12, a minus 3 plus 9 less than 0. Okay, 36 plus 12, a minus 12, 3 is 36, plus 9 less than 0, 12k less than minus 9, a less than minus 9 by 12, 3 3 is 3, 4 is a less than minus 3 by 4. Okay, so it means our a belongs to minus infinity to minus 3 by 4. Okay, now this will label it as inequality second. So from first and second, we see that if we combine the first and second inequality, our answer will go from minus infinity to, a will belong to minus infinity to minus 3 by 4. Okay, and we now take this one, because our here it is telling us that it is already negative, our answer is negative, so this we will not take this. Okay, you can write it like that, or you can write a is less than minus 3 by 4, anywhere you want. Okay, so in this video we saw what were the conditions for any number k to lie between the roots of any quadratic equation. The conditions were d greater than 0, because why? Because first of all, for any number k to lie between the roots of a quadratic equation, the roots should be real. That's why the condition 1, and the condition 2 is a times fk is less than 0, and based on that we how we solved the question that I showed you. So okay, that's it for today's video guys. So bye bye, take care. I'll see you in the next one.